back. Today we are going to talk about converting quadratic expressions to standard form from factored or vertex forms depending on which form you are given. So as you can tell from the title that we have a couple of different forms of quadratic expressions. So there are actually 3 different forms. The first form is going to be standard form. Okay, it's ax squared plus bx plus c. The second form is factored form, so factored. In Algebra 1, you learned how to factor quadratic expressions. We will be revisiting that probably tomorrow. And when we write factored form, it looks like a times x minus r1 times x minus r2. They use r because there is another word for zeros or x-intercepts, and they call that roots. So if you see the word roots, that just means zeros, which again are your x-intercepts. Okay, and so you can guess that the factored form can show us some really cool things about the quadratic expression if I wanted to graph that. Okay, and then the third form of quadratic expressions is the vertex form, which we looked at yesterday when we talked about transformations. So it's also known as the transformation form. And so that vertex form is a times x minus h squared plus k. Right. Each of these forms are unique in that they tell us different characteristics about the graph of the quadratic expression. And we will talk about that later on as we look at graphing quadratic equations. Okay. For today, however, we are just going to convert from one form to the other. Okay, so let's look at converting from factored form to standard form. Okay. We are only going to convert to standard form today. So we're going to go factored to standard and vertex to standard. And that's because we're going to learn later on how to go from standard form to those other 2 forms depending on what it is we are wanting to identify from that equation. Okay, so let's look at our first example. I want to go, let's do x minus 3 squared, not squared, x minus 3 times x plus 5. Right, so this is basically multiplying polynomials. You know how to do that. I'm going to use the FOIL or distributive method. And so the first step is take this first term, and I'm going to distribute it over. So x times x is x squared. And then I'm going to distribute it to the second piece. So x times positive 5 is positive 5x. And then I'm going to take this negative 3 and distribute it. So that's negative 3x and negative 15. After that, you want to combine like terms. So x squared plus 5x minus 3x is going to give me a plus 2x. So I get x squared plus 2x minus 15, and that is your standard form. Right, let's look at another one. 2x minus 3, x minus 4. So we're going to convert from this factored form of 2x minus 3 times x minus 4 back to standard form. Right? So again, we're going to distribute. So 2x to x is 2x squared. 2x to negative 4 is negative 8x. And then negative 3 to x is negative 3x. And negative 3 to negative 4, be very careful, that's a negative times a negative, so that is a positive 12. Right. Again, once you combine like terms, you're going to get 2x squared. Negative 8 and negative 3 is negative 11, so that's negative 11x plus 12. And that is the standard form of that. It's important to note that these are equivalent forms of these quadratics. So I know that 2x minus 3 times x minus 4 is equal to 2x squared minus 11x plus 12. Okay, so they are equivalent. Okay, and so that's an important piece to know that. Okay, here's one for you to try. So it's 3x plus 2 times 2x minus 1. So you can go ahead and pause the video and try that one, and then you can unpause the video to check your work. All right, hopefully you have paused that video and have worked it out and are just eager to check to see if you have the right answer. All right, so distributing, I get 6x squared minus 3x, and then 4x, and negative 2, and so I get 6x squared plus 1x minus 2, and that is the answer. All right, so that's converting from from factored form to standard form. Okay. All right, so let's look at the other converting. So we're going to convert from vertex form to standard form. Okay. So our first example that we're going to look at is going to be x minus 5 squared plus 3. Okay. So if I want to go from vertex form to standard form, I'm going to have to employ my order of operations, and I'm going to address this squared component first. Remember that when you square something, that means you're multiplying it to itself. So that is x minus 5 times x minus 5. And I still have that plus 3 at the end. Okay? So all I've done is just expanded that square notation So now what I have is something that looks like the previous problems with a piece tagged on the end. Okay, that's important because a lot of times students will say that x minus 5 squared equals x squared plus 25, and that is definitely not the case. Okay, and that's because when you do that, you're forgetting those inner and outer terms from where you FOIL. Right, so if I FOIL this, I have x times x, which is x squared, and x times negative 5, which is negative 5x, and then negative 5 times x, which is negative 5x, and negative 5 times negative 5, which is positive 25. Okay, and then don't forget that plus 3 that's down on the end. Okay. So combining like terms, I get x squared minus 5 and minus 5 is minus 10, so minus 10x. And then 25 and 3 is 28. So x squared minus 10x plus 28. Let's look at another one. So we're going to take a look at x plus 4 quantity squared minus 5. Right, remember to expand that x plus 4 squared, so that's x plus 4 times x plus 4, and then minus 5. Right, we're going to distribute, so x times x, which is x squared, x times 4, which is 4x, and then 4 times x, which is 4x, and 4 times 4, which is 16, and then of course I don't want to forget that minus 5 at the end. Right. Combining like terms, I'm going to get x squared plus 8x plus 11. Clean that up a little bit. All right, x plus 6 squared minus 8. All right, so what I want you to do is go ahead and pause the video, I give this one a try, and then come back and we will check your answer. All right, so we're going to expand that, take on that minus 8, foiling, I get x squared, 6x, 6x, and 36. Don't forget the minus 8. Um, 36 minus 8. And I believe that's going to be 28, but I'm going to double check. That is 28, so plus 28. Right. And that is your answer. Right. That is how you convert from either standard form or from either factored form to standard form or from vertex form to standard form. Right. You have a Delta math assignment that is going to be converting to standard form. Right. And again, you're going to have a unique ID with each problem, so be sure to show your work for credit and record that unique ID for each problem. Okay, so don't forget that on your paper.